This lesson demonstrates how to graph the most basic of all quadratic functions, which is y equals x squared. After we graph y equals x squared, we'll use a calculator tool to look at how changing the equation will translate or move the graph around the coordinate plane. So to graph y equals x squared, just like graphing anything, it's often useful to make an xy table. So if x is 0, you're going to plug that in for x and square that. You'll discover that y is also 0. So let me clean this up a little bit. So 0, 0 is on the graph. So that's 1 point on the graph. Now, suppose x is 1. Well, if you square 1, you get 1. So that means the point 1, 1 is on the graph. Now, what if you plugged in -1 for x? Well, when you square -1, you also get +1. So -1, 1 is on the graph. Okay, if you plug in a 2 for x, you square that, you get 4. Notice that when you plug in a -2, you also get +4. So +2, 1, 2, 3, 4 is on the graph, and so is -2, 4. All right, if you plug in a 3 and square that, you get 9. And similarly, if you plug in -3 and square that, you also get 9. So when we graph y equals x squared, we get this shape. It's not linear, it's not a line, it's a curve, and it keeps going. It's called a parabola. And any quadratic function will have a graph that's a parabola. Quadratic means the highest power on x is 2. So anytime you have an equation where the highest power on x is 2, you're going to get a parabola. Now, we're going to look at how we can change the equation slightly and change the graph correspondingly. So on this screen, what we have is a graph of y equals x squared, and you can see right here, that's what's showing. That means x to the power of 2. And you'll notice that my x coordinates go 1, 2, 3, 4, 5, whereas my y coordinates go 6, 12, 18, 24, and 30. That just makes it easier to show the parabola. So now we're going to look at what happens if we graph y equals, wait, where are we? Let's now graph y equals x squared plus 6. Okay, so I'm going to enter that here. I guess I need to do this. Y equals x to the power of 2 plus 6. Okay, so notice in blue, when we added 6 at the end of the equation, the blue graph is now 6 units higher than the original graph of y equals x squared. All right, so what if I did x to the power of 2 plus 18? Okay, that's now going to appear in green. Okay, notice it went up even higher. And you might look at that and say, oh, it went up 1, 2, 3 units, but remember we're counting by 6's here. So when we added 6, it went up 6 units. When we added 18, it went up 18 units. Okay, how do you suppose we could move the graph down? Well, let's try x to the power of 2 minus 12. Okay, think about where that might be on the graph. And then let's see if you were thinking correctly. Okay, there it is. It moved down 12 units. Okay, so that shows you how you can move a parabola up or down. you can also move a parabola side to side. So if I square x minus 2 and take that to the power of 2, now let's draw that graph. Alright, notice what happened. Instead of moving up or down, it now moved, in this case, to the right. Okay, so when we did x minus 2, it moved to the right. Let's try x minus 3.5 to the power of 2. Let's see where that moves the green one. Okay, so when we subtracted 3.5, the graph moved to the right 3.5 units. Okay, how do you think we can move the graph to the left? Well, if subtracting moved it to the right, I'm going to try x plus 3 to the power of 2 and draw that one. Okay, so that moved it to the left. Okay, now, turns out we could also we could take the graph of y equals x squared, and we can move it sideways and up or down in one equation. So if I do x minus 2 squared, that's going to move it 2 units to the right. And then suppose I say plus 12. That's going to move it 12 units up. Okay, so the minus 2 moved it over 2, and the plus 12 moved it up 12. So what used to be at the origin is now right here. Okay, for your homework, graph the following equation on graph paper, y equals x plus 3 squared plus 2, and then explain how that compares to the graph of y equals x squared.